Okay, shall I start now? And today we are going to have some numericals. Okay, write the first example. Example number one. Example number one is, consider a body started from point A, reached to point B, then move ahead to point C. And the distance between A to B is x1, and x1 is, let it may be 100 meters, and x2 be 200 meters. Similarly, x1 taken a time t1, and t1 is nothing but 20 seconds, and t2 will be 10 seconds. Question is, find V average. Okay. Then second is average velocity. Calculate the answer. Okay, shall I now? So average speed formula is V average is equals to total distance upon total time, and the total distance is 100, 200, 300 upon 30 seconds. So can I write 10 meter per second? Similarly, average velocity formula, displacement upon time, or final position minus initial position, whatever you want to write, delta x upon delta t, which is equals to, can I say again, 300 upon time is 30, or you can also write this as final position is here. So x final, this is your x initial, and x initial should be considered as 0 and final as 300 now. Final position minus initial position upon time, that is again 30. Whatever you want to write, you can write. And this is also 10 meter per second. So whenever the object is moving in a straight line without changing the direction or without retracing its own path, then can I say that again V average is equals to, in this case, average velocity and average speed both are equal. Write down fast. Example number 2. Body started from point A, reached to point B. Let this be 1000 meters. Taken time x1 50 seconds. Then the object is returning back here to a point C, and A to B, let it maybe 500 meters, and took a time t1, that is 100 seconds. Same question, find average speed, average velocity. Come on, be quick. Okay, shall I? So V average, that is average speed, is nothing but total distance upon total time. Total distance is 1000 and this 500. That means, can I write 1500 upon total time 150 seconds? This is 1 tenths, 10 meter per second. Or average velocity, final position minus initial position upon time now. So x final minus x initial upon time. This is your final position and this is your initial position. Final position is what? 500. Initial position is 0, so divided by 150. So 500 minus of this one 0, that becomes 500 upon 150. 10 upon 3 meter per second. Can I say that in this case V average is not equal to velocity? Whenever the object returns or changes its path, average speed and average velocity will not be equal. Okay, one more question, and we will try to change the in negative form. Consider object started from here, A, and this is B, this is your 500. Then object returned back in this direction and reached to point C. Consider this is 1000 meters. Time taken here is take 20 seconds. Over here take 10 seconds. Sorry, T2, 10 seconds. Come on, be quick. Okay, shall I now? Let us calculate first average speed. Average speed is nothing but again total distance upon total time now. And total distance is 1000 and that 500, that is what, 1500, and total time, that is 30 seconds, 0, once, and this 550. So 50 meter per second. Similarly, average velocity, final position, initial position upon time. And sorry, final position is 1000 minus of 500. But 1000 in which direction? In this direction, na? 1000 is in this direction. So this 1000 should be written with a negative sign. So minus 1000 plus of 500 upon time 30 seconds. So this is nothing but minus 500 upon 30, that is minus 50 upon 3 meter per second. Similarly, can anyone tell me V average in terms of magnitude? Magnitude of average velocity. Generally, what students make the mistake is, whenever we ask the magnitude of average velocity, they tell this answer. Okay. Magnitude of average velocity is nothing but final position minus initial position's magnitude upon time. Velocity is always represented by displacement. Okay, what is our displacement? Minus 500. Minus 500 upon time is 30. That means this can be written as minus 500 upon 30's magnitude is nothing but 50 upon 3 meter per second. Over here, all we need to remove this negative sign. That's it. Without direction. Without average velocity's magnitude is not equal to this velocity. So V average velocity's magnitude is not equal to average speed when the object is changing its path. Got my point, everyone? Thank you very much. Now, shall I? Do you remember displacement vector? When we write displacement vector is nothing but final position minus initial position. Now, similarly, if someone asks you what is velocity vector, then you will be writing delta V is nothing but final velocity minus initial velocity. If they are asking the magnitude, the same can be written as with magnitude. Okay? Shall I? Now, the question is, try this question. Consider a body is moving in clockwise direction and the body took 1 round in 40 seconds and the body traveled for 2 minutes 20 seconds. Yes, 2 minutes 20 seconds. Then find V average, average velocity, then magnitude of displacement vector. Try this answer first. Okay, shall I? Let the radius be R. Now, average velocity. Let us talk about average velocity first. So, average velocity, let's start with average speed first. Average speed is nothing but 1 round means 2 pi r. 1 round is 2 pi r. And 2 minutes 40 seconds is nothing but 140 seconds. Can I say that? That means it is taking how many rounds? 2.5 rounds. Sorry, 3.5 rounds. So in 140 seconds, body is completing 3.5 rounds. That means one round is 2 pi r, 2 pi r, 2 pi r. Total distance is 3 rounds into 2 pi r plus of half round, that is pi r upon total time 140 seconds. That means average velocity speed becomes 67 pi r upon 140. Take r value anything, 1, 2, 3, if r is equals to 1. If this is equals to 1, then this becomes, substituting the value, 7 pi upon 140 once, and this becomes twice, that is pi upon 20. First is done. Second, average velocity. To calculate average velocity, where is the body's position, we need to find first. So body is traveling starting from here, 1 round, 2 and 3.5 means body is stopping here. Okay, that means, can I say that this is your displacement, and the displacement becomes this r, and this also becomes r. So average velocity is nothing but 2r upon 140 seconds. 70 r value, if we take 1 upon 70 meter per seconds. And the third question is velocity vector. Initially, when the body is at, let this point is A and this point is what? B. Initially, body is moving in a clockwise direction. That means in this direction. And then the body is moving in this direction. Are yes or no? Okay. I need the board. Shall I rub this one? Okay. Now, third is velocity vector. Velocity vector is v final minus of v initial. Now, the reason is, first thing, body started from here. Body is continuously moving. Body is moving with a speed of how much? That is pi by 20 now. Pi by 20 is unchanged. That means constant speed. If body is moving with constant speed, that means at this point the speed is same, at this point the speed is same. The only thing that changes is the direction. At this point, at point A, the body is moving in this direction. And at point B, the body is moving in this direction. That means we need to calculate the mod. And then this average velocity can be calculated under the root of VA square plus VB square minus of 2 times of VA, VB. What is the angle between the point A and point B? At A, body is moving in that direction. And at B, body is moving in this direction. That means, can I write cos of 180 degree? Yes or no? So, delta V is nothing but this and this both are equal. VA and VB are equal. So, V square plus V square under the root of 2V square, and cos 180 is minus 1 and this becomes plus. So, this 2V square, or delta V is nothing but 2V, and what is V? What is speed? Pi by 20. So this is nothing but 2 into pi upon 20. This and this get cancelled, that is pi by 10. Velocity vector is how much? Pi by 10. Note down fast. One more same type. Point A is your initial position, and let be, this is a watch. Consider this as a watch, and this watch is having a second hand, and second hand is moving for a time period in this direction. T is equals to 15 seconds. This is your final position. Point B, let this radius be 1 meter. Okay, anything required? Initial, final, time, done. Everything is done. Calculate V average velocity. Average speed, average velocity, then delta V. Come on. Okay, shall I? First one. What is first? Average speed. Average speed is total distance upon total time, and total time. Total distance from here to here 2 pi r. Half becomes pi r, and this quarter become pi r by 2. So pi r by 2. Pi r by 2 time is 15 seconds. That means, can I write pi r value is given 1 pi upon 30 meter per second. Average velocity. Average velocity means final position, initial position. This one is 1, this one is 1, this remains 90 degree, this becomes root 2. Are yes or no? Now, displacement is how much? Root 2 upon time 15 meter per second. Third, velocity vector is nothing but final velocity minus initial velocity. Why again? They are changing the direction. Now, to find that, we need to find the angle first. At point A, this one is moving in this direction, and at point B, the direction is here. That means, can I say still the angle is 90 degree? Then delta V is nothing but under the root of V square plus 2V square, minus 2V square cos of 90 degree, cos 90 0. So the whole term get cancelled out. So mod of delta V is nothing but V square root 2 V, and V, what is this V? Velocity or speed? Speed, very good. That means pi by 30. So this becomes root 2 pi root 2 upon 30. Fair and also. Write down first. Okay, now, given that x is equals to 2t square plus 4t minus of 6. This is the given equation. And body traveled from t1 is equals to t2 seconds to t2 is equals to 4 seconds. Question is, find average velocity. I will do one, you have to do one. Okay, now whenever you will be finding this type of question, first thing we need to find V average is always equals to final position minus initial position upon time, or we can also write delta t. Yes or no? Final position, that means this is the final time. For initial position, this is your initial time. Substituting these values, then this becomes 2t square plus of 4t minus of 6. Here you should be substituting t is equals to 4 seconds. Then minus of initial, same equation, 2t square plus of 4t minus of 6. Here you should be substituting t is equals to how much? 2 seconds. What is the difference in time? 4 seconds, 2 seconds means 4 minus 2, 2. Okay. After substituting the value, we get V average is equals to 4 square 16, 16 to 32, 32 plus of 4 16 minus of 6. Then substituting t as 2 over there. So 2 into 2 square 4 plus of 8 minus of 6 whole divided by 2. Okay, solve this. So V average 10, this 32, 42 minus of 8 plus 2, 10 divided by 2. That means 32 by 2, that is 16 meter per seconds. Write down first. Okay, now let us move to the instantaneous topic. You should be knowing two things, integration as well as the differentiation, to understand this. Whenever we are moving from displacement or distance to velocity, we need to differentiate. And if velocity is given, they ask you to calculate distance, you have to move to integration. All we need to remember only two basic formulas, very small formulas. For differentiation, you should be remembering x to the power of n is nothing but nx n minus of 1. And for integration, you should be remembering x to the power of n can be written as x n plus of 1 divided by n plus of 1. Okay, these are the two basic formulas you have to remember. That's it. Let us try to understand with example. So example number 1, given that x is equals to 2t cube plus 3t square plus, let it may be 4t plus of 5. Here is the value. They will provide you this equation and they ask you find the velocity at t is equals to, let it may be 1 second for simple simplifications. X is given, we need to convert to velocity. Differentiation or integration? Differentiation. Okay. So whenever I differentiate with respect to time, so dx upon dt, this is nothing but your v. And d as it is, substitute over here, 2t cube plus 3t square plus of 4t plus of 5 on dt. Apply that equation, differentiation equation. Then this becomes 2 as it is, 3 comes to the denominator, 3t, 3 minus of 1, 2, plus of 3 as it is, this 2 comes to the denominator, t, 2 minus of 1, 1, plus of 4 as it is, t, 1 minus of 1, 0, so this becomes nothing, 4, and constant is having a value 0. Now you will be having v is equals to 3 to 60 square plus 3 to 60 plus of 4. Substituting the value t is equals to 1 second. So v is equals to 6 into 1, 6 plus of 6 plus of this 4, 10, 16 meter per second. This is how we do when displacement is given and they asked velocity. Write down first. Now the next question is example number 2 on this topic. V is given. Let v be 3t square plus 2t plus of 4. Find x at t is equals to 1 second. Now, whenever velocity is given and asked displacement, all you need to apply what? Integral formula. What is our integral formula? So, integration of v. First thing, v is nothing but dx upon dt. We write like this. Yes or no? What do we want? This one. So, dx is nothing but v dt. Yes or no? All we need to integrate like this. Okay? We are not doing mathematics. Don't worry. You can write anything. So, v, applying this v, integral of v is what? 3t square plus 2t plus of 4. This is nothing but your displacement and integrating this. So, x is equals to 3 as it is. T square, that means 2 plus of 1 divided by 2 plus of 1. So, t cube divided by, can I write 3? Plus of 2 as it is. Nothing means 1 always. 1 plus of 1 divided by 1 plus of 1. Na? So, t square by 2 plus. This becomes 40. In integration, if you don't have any value, that means this one is a constant. Whatever with the thing you are integrating, you have to substitute t. We are integrating with respect to time now. All you need to substitute 1t. In differentiation, constant becomes 0. Okay. Now, so x is equals to this 3 get cancelled, 2 get cancelled. So t cube plus t square plus 4t. Substituting the value, t is equals to 1 second. So x is equals to 1 plus 1 plus 4 6 meters. Okay. Okay, now question is given like this. Here is the origin. From here 14 meters and on y-axis 4 meter. One point is there here. That means the coordinate is given 14, 4. Velocity along x-axis, that is Vx, is given, that is 8t minus of 2, and velocity along y-axis Vy is given 2 meter per second. Okay, and they ask you write the equation of path. Okay, try this first. Then see the question, what are the things given and why these coordinates has been given. I will tell you how to do. Vx, differentiate this, integrate that, you will be getting displacement. Okay, then equate with 14. Why? Because it is with 14 x-axis. Similarly, Vy, integrate that, you will get displacement in y-axis with 4. Try this. Okay, stop writing, I will do now. Now, first thing, Vx is given. So Vx is nothing but 8t minus of 2. If I want to convert this in displacement, I have to integrate this. To integrate this, what is our formula? Vx is nothing but dx upon dt or dx is nothing but Vx dt. Can I write like this? Okay. What are the things given? Time period is given 2 seconds. For time period, t is equals to what? 2 seconds is already mentioned in the question. Okay, now from where to where? X-axis 14, we don't know where, till x. They can give you the value, find the equation for 16 seconds, 20 seconds or so on. Or generalize from 14 to x, any value. Time period is given from 2 to t. This is how we write. Now, the next thing, Vx is what? 8t minus of 2. So this can be written as x minus of 14, which is equals to upper limit minus lower limit. Then Vx is what? 8t. Integrate this one. If you integrate this, 8t square by 2 So 8t square upon 2 minus of this becomes 2t. What is your upper limit? T, and lower limit is 2. Can I cancel this ones and fours? So x minus of 14, which is equals to 4t square minus of 2t. Okay. Now, all you need to substitute the value of t and 2 in that t formula over here. So x minus of 14, which is equals to upper limit 4t square and t is t minus of 2t minus of lower limit 4. Now t square becomes 2. So 2 means this becomes 4 minus 2 and 2, this becomes 4. 16 minus of 4, 12 minus. So x minus of 14, which is equals to 4t square minus of 2t minus of this is 12. Got my point? Okay. Then after simplifying this, 14 becomes here. So x is nothing but 4t square minus of 2t then plus of 2. This is your x value. Similarly, finding the y value. And in Vy, so Vy can be written as dy upon dt. And this can be written as dy is equals to Vy dt. Again integrating this. Integrating from what to what? Displacement in y-axis is from 4 to x, y. This is your 4 and this is your y. Integrating this is from 2 to t. Now substituting the values. So this becomes y minus of 4, which is equals to vy. Vy is how much? 2. So this becomes 2t. Upper limit is what? T, and lower limit is 2. So y minus of 4, which is equals to 2t minus of 2 to the 4. Can I cancel this? Minus 4 and minus 4. Okay. Then y is what? 2t, or t is what? Y upon 2. Substituting this value in this equation. Substitute and tell me that is your answer. Okay. So final value, x is equals to 4. T is what? Y square upon 2. 2 means this becomes 4. Then minus of 2t. So 2 into y upon 2 plus of 2. So final x value is, x is equals to 4, 4 get cancelled, 2, 2 get cancelled. Y square minus of y plus of 2. Okay, try this. V is equals to, given that AT plus BT square, where A and B are constants, and find x between t is equals to 1 second to t is equals to 2 seconds. Simple. Apply the same equations whatever you have applied in the last question. Okay, try this. Okay, stop writing and listen to me now. Vx is given. All we need to, v is nothing but dx upon dt. Are yes or no? And dx is nothing but v dt. Integrating this from what time to what time? From 1 second to 2 seconds, and we don't know the time. Let if we are starting from 0 to what? Your x. So this becomes x is equals to v. V is what? AT plus BT square. Integrating this one, A remains constant. Let me write this. AT plus BT square. Okay, now integrate this. X is equals to A as it is. This becomes t square upon 2 plus b square t cube upon 3. And apply the limits. 2 to 1. Upper limit is 2, lower limit is 1. X is equals to A, applying t as 1, 2. So 2 square 4 divided by 2 plus of b to t cube is 8 upon 3 minus of lower limit at by 2 plus b cube by, at square by 2, and t is 1 now. So 1, 1, 1, everything becomes 1. 3. Okay, now t value is 1, lower limit. That's the reason I didn't mention anything. So x is equals to 4, and that means this it cancel. 2a plus 8b upon 3 minus of a by 2 plus of b upon 3. Sorry, this also becomes minus. Solving that, solve this. X is equals to 2a minus of a by 2 plus of 8b upon 3 minus b upon 3. Two, 4, 4 minus of a, 3a by 2, 3a by 2 plus of 7b by 3. Okay, now I will dictate the question. Start writing the question. The horizontal and vertical displacement. The horizontal and vertical displacement of a particle moving along a curved line. The horizontal and vertical displacement of a particle moving along a curved line are given by x is equals to phi t. X is equals to phi t and y is equal to 2t square plus t. Y is equals to 2t square plus t. Full stop. Time after which its velocity vector makes an angle of 45 degree with the horizontal is. Read the question, then try the answer. It is moving in a curved path. First thing. Second thing, x is given, y is given. X is given phi t and y is given how much? 2t square plus of t. Na? And they are asking you the time period. Find the time period. Angle is given 45 degree. Angle, whenever the angle is given 45 degree, that means x and y both at those coordinate become equal. Na? Come on, try this. Okay, anyone got the answer? T is equals to question mark. Anyone got the answer? No? Okay. X is given. Y is also given. Can I say this is the coordinate along x-axis and this is the nothing but displacement along y-axis? Not a coordinate. This is displacement along x-axis and this is your displacement along y-axis. They are asking you the time. So can I say that Vx is nothing but differentiating of this x, that is dx upon dt. This is nothing but d of phi t with respect to time. This becomes phi. So velocity along x-axis is 5 meter per second. Can I say that? Okay. Similarly, y. So velocity in y-axis is nothing but dy upon dt, and this can be written as 2t square plus of t upon dt. So Vy is your 4t plus of 1. Okay, this is your velocity along y-axis and that is your velocity along x-axis. Given that it is making an angle of 45 degree, that means, for example, this is your Vy and this is your Vx. Okay, it is making an angle of what? 45 degree. That means if I make an angle 45 degree here, then can I say this becomes 90? Obviously this becomes 45 degree. If these two are 45, that means opposite sides are equal. Now this is your Vy and this is your Vx. So Vx and Vy become what? Equal. So Vx is equals to Vy. Why we are doing this? Because given theta making with horizontal is how much? 45 degree. Okay, and Vx is what? Phi, which is equals to Vy 4t plus of 1, or this becomes over here. So 4 is equals to 4t. So time is equals to 1 seconds. No one got the answer now? Excellent. Okay, shall I dictate the next question? A particle moves along x-axis. A particle moves along the curve. A particle moves along the curve. Y is equals to x square by 2. Y is equals to x square by 2. Here x varies with time. Here x varies with time as x is equals to t square by 2. So x is given t square by 2 and y is given how much? X square by 2. Y is given x square upon 2. Full stop. Where x and y are measured in meter, where x and y are measured in meter and time in seconds. At t is equals to 2 seconds. At t is equals to what? 2 seconds. Find the velocity of the particle. Velocity of the particle is question mark. Okay, shall I now? He is asking velocity. So differentiating this first. V is equals to dx upon dt and dx is nothing but t square upon 2. This can be written as 1 upon 2 t square becomes 2t. T get cancelled. This becomes how much? Only t na? Yeah, 1 by 2 into 2t. 2 cancel. Only t na. That's what I said. So this is along x-axis. So velocity along x-axis is just t. Or can I write I cap? Let's pakad isko. For t is equals to 2 seconds. Or you can also write Vx is equals to 2 I cap. Okay, then calculating velocity along y-axis. Okay, y is nothing but varying with x. X is what? T square by 2. So y is equals to x square by 2, or this can be written as x is t square upon 2 cos square whole divided by 2. Huh? So t to the power of 4 divided by 4, 8. So y is nothing but t to the power of 4 upon 8. Can I write like this? T square into t square. T to the power of 4. 2 square become 4. 4 into this 2, 8 na. Okay, now. So Vy is nothing but dy upon dt, or this can be written as differentiating 1 by 8 into 4 t cube. Once, twice. So Vy becomes t cube upon 2. Okay. Or substituting the value of t is equals to 2 seconds, then we get Vy is equals to 2 cube is 8 upon 2, that is 4. This is along j cap. So final velocity V is nothing but Vx plus of Vy na, or V is equals to Vx 2 I cap plus of Vy 4 j cap, that is in meter per seconds. Okay.